Hey everyone, thank you so much for joining the Behind Company Lines podcast. Today we're interviewing Julian Hoffman, CEO and President at Chia Network. Chia is a technology infrastructure company building a transformative open source public blockchain focused on real world utility that are secure in approach, regulatory compliant, and sustainable by design. Julian, I'm so excited to chat with you, not only what you're working on currently and how you're really affecting kind of the implementation of this technology. We all think about Web3, we all think about tokens and NFTs, but really there's this underlying just like adoptable kind of new age transformative technology kind of that can implement in all these underlying functions that a lot of people don't think about today, but you can see the application of them and you see their value. So obviously we'll dive into that and kind of what all that means and what you're working on at Chia. But before we get into that, what were you doing before you started the company?
Well, so I've built and sold a long list of companies. So my first company, we invented internet ad blocking and sold that to PGP Inc., which was kind of the granddaddy crypto company. And then when PGP was sold to McAfee, I almost started a cryptocurrency then in 1997, but instead ended up starting what was emusic.com and helped launch the iTunes music store and the iPod with Tony Fadell. Then after Vivendi kind of broke up their music industry situation, I started an infrastructure company for subscription services that sold to Amdocs about 7 years ago.
It's incredible to think about. You almost built blockchain back in 1997. What was the technology like that? What were you kind of, what got you introduced to that technology, and what in particular did you see in terms of its longevity, and why essentially didn't you build back then and choose to build around it now?
Well, so it was the intersection of the coming internet and cryptography becoming a normal thing that individual software developers could actually implement.
Yeah.
And so at PGP, it was, can we take back the ability to know who's listening to what we're saying? And we actually have control of who talks and who could share a secret or not share a secret. And it was very clear that that would also apply potentially to financial transactions. And at the time, the state of the art was what's called Chaumian digital cash after David Chaum. And there was a real seminal breakthrough in 1997 that was double blind RSA signatures. Nobody needs to care. It basically meant that you could have true anonymity in how a digital cash bank could work.
Yeah.
But, I think the best way to explain why we didn't have cryptocurrency then is my then girlfriend, now wife, said, so you're telling me that we'll have to live on a strange Caribbean island surrounded by armed guards? Yeah. Coming back to the United States? Probably not. You should do that music thing. So we thank Satoshi for finally fixing the single point of failure problem, right?
Yeah.
Because of course, if you had one entity that was the bank, that bank is going to be the target for the entire international world to regulate or worse.
Right. And why wasn't it, essentially, was it that barrier for most developing around the technology that's led to that kind of the progress of that not coming out until later? And what essentially did you see in kind of this renaissance around the technology, and why people were getting, obviously there was this boom around tokens and things like that. But, once technology started getting built around it, kind of Ethereum and that framework, what did you really see on how adoption really started to pick up?
Well, so there's a huge breakthrough that is Nakamoto consensus. So there's a lot of subtle math there. There's a tremendous amount of understanding applied cryptography and game theory and a lot of learning from BitTorrent, the coin named in homage to BitTorrent. So when you pull all those things together, you finally had a solution for the double spend or single point of failure problem, because that was the same reason you had the single point of failure in the past.
Yeah.
So it really proved that it was finally a technology that we could layer a trust infrastructure and a transaction infrastructure on. But both it and then later Ethereum have some significant flaws.
Yeah.
We did not see the real world pick up and use Ethereum and Solidity because there are real risks from a security perspective.
Yeah.
And the kind of development history of Bitcoin is that we don't really have smart contracts on Bitcoin.
Yeah.
And so if you could get a Bitcoin that had smart contracts and also didn't use all that electricity, like maybe 300 times less electricity, then you would really totally take back the objections that governments and banks and others had for putting real money on blockchains. And so Bram and I set out to solve for the energy problem of Bitcoin, and then most importantly, build a Bitcoin style smart contracting environment. It is a much more secure environment. I mean, Bitcoin is really right about how it is much easier. It is much easier to self-custody.
Yeah.
You really can reason about your assets. You audit them cleanly instead of having all these reentrancy problems in North Korea stealing 1.3 billion last year of Solidity contracts.
Yeah.
We had to fix that problem and give people a trustworthy programming environment to then get folks like the World Bank and the IFC and the nations that are behind the Paris Agreement Article 6.2 to really look at this as a technology they could use to solve real problems.
Yeah.
And so we're in the early days of that, but we're really bringing new use cases to blockchains where they make a ton of sense.
Yeah. And for those who don't understand, what are the risks or what are the security risks with the other technology that Bitcoin kind of, I guess, mitigates? Is it, and what are the reasons? Is it because of the simplicity of it? Is it the way that it's built in terms of the logic? What in particular kind of are the risks? What are the difference between the currencies and, or even just the mechanics behind the machine that make it maybe riskier or less risky?
So there's really kind of two ways to go about keeping the data in a blockchain. Bitcoin and Chia go about what's called the coin model. Sometimes you hear it called the UTXO model. And the idea is like everything that changes is just some coins get created and some coins get destroyed.
Yeah.
Now, the logic inside those coins can be a Turing complete computer. So you actually have the ability to do all the things you might want to do about, hey, is this trade going to be close enough to the price oracle that it should go through or not? In Ethereum, they took a very different approach. You have a kind of centralized smart contract that keeps a list of all of the kind of values of ownership that come out of it. And so it causes all sorts of interesting problems because it's kind of a state machine where you might not know how somebody could kind of go through your program in a way that you didn't intend it to, and therefore convince it to unlock funds that it shouldn't. I mean, this is what North Korea kind of does on a weekly basis, right?
Yeah.
And it doesn't work real well from a performance perspective either, because you have a really popular smart contract. So like a really popular asset or a really popular class of NFTs, any transaction has to update that specific central smart contract.
Right.
Where like in Chia or Bitcoin, if I have a really popular NFT and I want to sell it to you, the only thing that gets updated is your coins and my NFT, not everybody else's NFT too, right?
Yeah.
And so you have a much better kind of truly peer-to-peer capability, and you have a lot better efficiency. And because you've got that kind of auditability, it's much easier to reason about, okay, what can you do with this NFT? Not what can you do with this NFT contract that has all of these different things that you could and couldn't do with it, right?
Right.
I like to joke, one of the things that we have is very different. It's called offer files, and you're starting to see this in inscriptions at Bitcoin as well, where I can propose to you to sell my NFT to you for X amount of money.
Yeah.
It's just a signed object. And if you accept it and meet the other side of it, you can put it through on a blockchain. And now we've done a peer-to-peer transaction with no smart contract in the middle. And you're doing this on Ethereum, it's peer to smart contract to peer. It's not truly direct peer to peer.
Yeah. And then what was the mechanics of the technology around Chia that allowed it to be more energy efficient and create smart contracts on, obviously, the mechanics must be different, at least from Ethereum standpoint, being that is it tied to the token or the coins, because it seems as though Solidity, you kind of build those contracts into the system. I'm just curious on the mechanics on how that works and how it has decreased kind of the overall energy cost.
Yeah. So there's kind of like two questions there, right? There's how do we fix the energy use problem and keep kind of proof of works security? I'll answer that one first in the sense that what Bram invented is kind of proof of work. So the way it works, it's called proof of space and time. So you take unused hard drive space, and like on the weekend, you might fill up a couple terabytes of your unused hard drive space. So you did some work there. You have to go out and kind of print out proofs. They're like bingo cards. And what happens is once you're done, you can now compete in every block by listening to the network and comparing the proof of time kind of announces like a bingo number, right?
Yeah.
And if you have a bingo number, you're close enough, you win the block.
Yeah.
So it's very energy efficient in that your hard drive is kind of idling until you are the person who's going to make a block. So you're not sitting there like constantly crushing new hashes out in compute like Bitcoin does, right? So it's not energy free, but we're about 300 or 400 times more energy efficient with the same security. And we actually happen to have the most decentralized network in the world. We've got about 120,000 farmers and a Nakamoto coefficient. This is how many different farmers are signing, of nearly 90. That compares to like Bitcoin at 50,000 and like a 2 or a 3 Nakamoto coefficient.
Yeah.
So even with all those farmers around the world, we use about the same power that Ethereum now does in proof of stake. And never expected it, but it kind of goes to the efficiencies and other things. And then the other question is, okay, so how the heck did we make smart contracts in the Bitcoin style, right? And I think it's important to back up and say that Bitcoin is almost exactly right. Like there's a whole bunch of the right security assumptions and good practices. And, understandably, it's been afraid to kind of go to that next step because to get there, it's had to make changes to consensus. It wasn't able to kind of start with a smart contracting environment.
Right.
Now, we actually think Lisp, which is what ours is, there's serious consideration by Bitcoin Core to adopt Bitcoin Lisp and follow the same basic model. Because once you kind of bite the bullet once, then all of your programming is now up an abstracted programming environment where people can create new things without having changed the underlying protocol.
Yeah.
But I mean, what we did is we looked at a list of, okay, if you were going to do it in a Bitcoin style, what are the major factors that would drive how you'd make that decision? And so one of the things is like, you want it to be interpreted, because an actual non-interpreted language could like escape on your farming machine and start to like search for your private keys. You don't want that bad, right? You need it to be deterministic. You wanted it to be functional. These are all things that describe Lisp. And it was really funny. We are not Lisp fans per se, but basically one of our developers, as we were whiteboarding this, was just like, we've just talked about a Lisp dialect, right?
Yeah.
And it's really funny. Lisp is all about lists. And when you think about what blockchain is, it's a really sophisticated list. And so by implementing Chia Lisp and kind of generalizing that capability, we were able to launch a blockchain that we don't have to touch much to change, but can really be as inventive as anybody wants to be at the smart contracting layer and get real auditability. So the trade-off is, it's certainly not as easy to write Chia Lisp as it is to write Solidity, which is kind of JavaScript.
Yeah.
But once you do, you know exactly what it's going to do. You can really deeply audit it. And the way we, instead of like in Ethereum, almost every developer has to write an entire smart contract. Often they start from somebody else, but in our world, a lot of developers will never write a Chia asset token. They will literally grab the primitive for Chia asset token, because the way it works in Chia and Bitcoin, the smart contract is the coin. So every coin is a smart contract, even the basic, like you have one Chia sitting there in your wallet. It's a little smart contract whose solution is your private key, right? So a lot of developers will end up using Chia Lisp in the sense of like, they'll have a TypeScript or a Go SDK to say, hey, create my Chia asset token with these parameters, and it'll just do it. You won't have to actually like write a Chia Lisp.
It's so fascinating thinking about the way that could be adopted, not in just in peer-to-peer transactions, but in harboring data or kind of holding some amount of value in it, whether it's data or it's actual kind of currency or anything like that. Describe for the audience like some ways that you've been able to use Chia and kind of its impact, and not only the progress we've seen up to this point, but what's particularly excited about the next phase of the adaptability of the technology and kind of new avenues you're looking into.
Yep. So, the first thing that had to be fixed for enterprises and governments was being truly decentralized, being truly sustainable, and then being secure at the programming language level. There's a lot of really good enterprise software developers at banks and governments who are worried about trying to use Solidity for real money, right? Yeah. And in fact, if you've seen what you've seen banks do, is they've run private blockchains, so a private copy of Ethereum, because then the North Koreans can't get on to actually steal the money, right? Yeah. But that's not the value. Like, the value is actually having the public chain so that you can interact with parties you hadn't expected to interact with yet, right? We have this technology we call data layer. And what it is a federated database. So there's this like internal tension in blockchains where people want to like put PDF files on their blockchain. This is a really bad idea. We have like 2,000 farmers in Ukraine during the war, and you do not want to push 2,000 PDFs to 2,000 farmers in Ukraine right now, right? So what this does is instead it says, okay, anybody can create a coalition database. And so one of the best ways to describe this is our partnership with the World Bank, IETA, and Singapore. This is the Climate Action Data Trust. And so the idea is that the voluntary carbon markets, there's registries. You may have heard of Vera or Gold Standard. And there's also national registries, Japan, the UK, Mexico. All these folks were participants in the final proof of concept. And this went live last December. They're integrating to it right as we speak. Instead of having just one registry, they actually have a meta registry on chain. And so the idea is that like Vera will have a read-write table for Vera's carbon registry. So a project comes and says, hey, I want to register this acreage in this time frame for this many tons of carbon. The first thing they're going to do is check the meta registry to make sure it's not been registered somewhere else first. Yeah. So once they register it, they're then going to put most of the details of it into the Climate Action Data Trust. The way this works is they make an update on their table and they publish the hash of that update. And anybody else in the Climate Action Data Trust will see that change on chain and will ask each other, like Mexico might ask Peru for Vera's change, right? Mexico grabs that, looks on chain and goes, yeah, this matches the change, an update that Japan made. Let me apply it to my read-only copy of Japan's table. And so this way you can keep a multi-party, totally spread database in sync and truly auditable and trustworthy, and do this between like governments and private parties. It's pretty hard for governments to like actually mediate with each other, but this allows them through transparency to make it almost impossible to cheat. If like, I'm only using this as an example, apologies to Sri Lanka, but like if Sri Lanka decided to go rogue and start like double printing carbon, everybody could see that.
Yeah.
And that's its own incentive not to do that.
Yeah. And what were they doing beforehand? They were just kind of keeping a public registry and everyone just kind of, it's within good faith.
It was an unsolved problem in good faith.
Yeah.
And this is a problem for the buyers, right? Because the buyers are kind of shooting dark of, did I buy something that's been sold twice or not?
Yeah.
They'd been doing they said was going to be an 8-year project to try to find a solution here. We ended at year 4. But before that, they'd done private blockchains and those sorts of things. But especially with the governments involved, private blockchain isn't a good solution because even though like most countries like Singapore, who's technically the host of this, there's some countries that don't. And the whole point is that you want everybody to be able to participate in this. And so now as a host, at most, they're the technical support number, not the persons who can grant or de-grant you access to this data set.
Yeah. And thinking of one thing that hasn't been proposed a lot on this podcast and in terms of networks that run similar projects or have infrastructure layers on Web3 is we talk a lot about consumers. We talk a lot about companies using it, different pieces of information, at least the stateside where we can use the technology. But what hasn't been talked about is like the communication aspect with other countries and all this work that's being done in transaction through countries that whether they have conflict or previous history, or maybe they're cooperating, maybe they're not. There's a state change always, even if there's a treaty or something in place that says you have to behave well. What does that mean in terms of the trust kind of layer to blockchain to allow countries to not only do, carbon credit transactions, but also do other things in business, whether it's transaction through tariffs or trades or things like that? How broad can, this technology have an impact in just the activities that countries do to one another? And what are some pros and cons that come with that interaction?
Well, so I think the other really big item beyond just international payments in general is the kind of supply chain monitoring and attestation, right? You have a lot of geopolitical fights over, did this lithium ion battery come from the right place?
Yeah.
Is this a blood diamond? Right. And from that perspective, you don't solve everything with the blockchain, but you do add a trust and transparency layer that you otherwise wouldn't have.
Right.
So you're still relying on things in the real world, FedEx to correctly check something in, or the shipper in Peru to enter the right data. But now you have a transparent, audited, time-bound record of all of that. So you can actually now go research and go, wait, I got something from the supply chain that didn't meet the quality specifications. Who signed off?
Yeah.
Right. And it's the ability to kind of go walk back and see that transparency engine means that people don't have the room to cheat as much in the first place.
Right.
Now, I will say there's probably some things where people still want to be able to cheat, and blockchains are bad for that. I mean, that's what the trade-off sort of is.
Yeah.
But, ultimately there's usually someone in that supply chain that cares enough and has enough influence as a buyer or as a consumer to be able to force that level of transparency on down. And so we see that like global trade, there's a bunch of things that day-to-day customers don't know about, but like the way that you actually like buy DRAM from a Chinese vendor and pick it up in Los Angeles, there's a whole bunch of bank transactions people don't know about. Those can go away. You can go to a world where you are like trusting only the shipper to sign off that the shipment's been received.
Right.
And they're the only person who can change that. And they actually cause the funds to flow. Yeah. And you can even have like a 30-day clawback after that like if the buyer disputes it, it goes back to the escrow. And all of a sudden you do this in a way that like, you don't trust the escrow agent, you only trust what they're saying.
Right.
It's a very different kind of model that you really can do. And when you talk about data layer and this other technology we have called offers, I'll give you the carbon version of this. Like Japan can propose to Peru, hey, if you make this change in your voluntary registry, we'll make this change in our voluntary registry.
Yeah.
And we'll sweeten it with $1 million. And you literally email that. And so Peru can look at that email and go, yeah, that's what we agreed to. They create their other side of the transaction, submit it on chain. And now you've got trustless, escrowless country to country trading.
Yeah.
Certainly can be done as if you're a DRAM wholesaler, right? It's like, okay, the DRAM market, we all have our own consortia, but somebody new in the computer business wants to buy some from us. I can prove to you that I own this in the Port of Oakland, and I can prove to you that I can transfer it to you. And all you need to do is show me on the other side that you make the payment. And if you do, we're done. You now have that bill of lading that says you own it. Right?
Yeah. Yeah. In thinking about just like this open source concept, obviously it's been around and it wasn't necessarily Web3 that created this concept, but it really got popularized with kind of the whole philosophy around building and the community aspect. What does that mean in terms of the efficiency and the velocity that you can deploy, say, dApps and DeFi protocols and other projects within blockchain, when you're able to communicate and build code with minds of different countries. And what are some of the exciting parts about that? But what are some things that people are, say, a little bit more skeptical about and concerned about when kind of thinking about building with just other parties outside of your own interests?
Yeah. So, when you think about the internet as a revolution, right? It was a revolution in like time, place, and information. But there were kind of two things that weren't naturally there. And one was there was kind of no transaction processing capability. I mean, you don't have a kind of native currency of the internet, right? And then the internet wasn't very good at necessarily the authenticity of the data. I mean, spoofing email is the thing we used to do back in the day, and you still really can actually. We all witnessed the spam problem, right? So what's really fundamentally interesting about open source public good blockchain is that you now have this trust layer that you really can certify which AI model was used to generate this LLM. Where did that lettuce actually come from and who signed off on it? And wait, I might be able to charge you to talk to me. And as long as you're willing to pay me enough, you'll get into my wallet and be able to send me a message that, hey, you want to buy my NFT or you want to buy my car. And those were problems we've always had on the internet, that all of a sudden having a globally distributed public good really changes. And it becomes a commons. I mean, like in the Climate Action Data Trust, because we're an American company, we certainly can't help anybody in Iran. But that doesn't mean Iran can't find people who understand the technology and absolutely participate in the Climate Action Data Trust. And in the grand scheme of like solving climate change, you can see why having this kind of neutral but public trust layer is extremely valuable.
Right.
Now, on the other side, we've only really seen the crypto casino, and that's a bad thing. I mean, we're watching the backlash here. The places where blockchain are going to take off, like Red Hat Linux took off in the financial infrastructure back in the late 90s and early 2000s, are going to be on the back end first. So, your average user may never see some of the huge fundamental changes blockchains will allow. Like as a carbon credit buyer, you won't necessarily know that the carbon credit was recorded on the Chia blockchain, tokenized on the Chia blockchain, and then retired on the Chia blockchain. You'll just see like on your Bloomberg terminal that you bought 50,000 tons of ISC class carbon and retired it. Right. And the same thing's going to be true for things like we expect to start doing things like auto loan origination on chain. Now, if you're an auto buyer, you're still going to like send your loan payments to the same loan servicer, but the loan servicer is going to pay out the loan owners on chain monthly, driving down the cost of capital because it's easier for them now to raise money and automate all those systems. So for now, a lot of this stuff is going to be kind of in the back end. Now, I think long term, 10, 15 years, you may very well be buying a cup of coffee with Chia at Starbucks. But that's going to happen more because like you're using this card that still looks like a debit card, but in fact is like using a secured wallet that your phone and a backup system mediate, and your security is just much better.
Yeah. And obviously it's a silly question, but what is the problems that this is solving? Obviously with carbon credits, the trust layer is just extremely valuable, and especially when I'm sure just high volume transactions and things like that. But what are the problems that it's solving on the back end layer that say we're not seeing that makes it so fundamentally critical to adopt this technology? I mean, we think about, oh, this is cool, this is new, there's a lot of trust layer, there's a lot of visibility, but for what? Is it for security? Is it for trust? Is it for the speed of transaction? What are the problem sets that it's solving that we don't see, and why it's so imperative to actually adopt the technology on the back end?
So it turns out there are very few technologies that have true finality. FedWire in the United States has finality in the sense that like if you send a wire to another bank, you can't get that money back from your bank. The best you can do is go to the other bank and try to get it there. There's one thing that kind of starts this, which is the ability to self-custody and truly control your assets is a kind of new phenomena. It's been almost impossible for normal folks or even institutions to like self-custody equities or debt or mortgage-backed security. Normal folks probably still won't necessarily self-custody like their own stock, but certainly large financial institutions would love to self-custody that stuff and like be directly in control of loaning it out when it's being loaned for margin and taking that money directly instead of like using a prime broker to do that.
Right.
And so the places where you're going to see it, like there's kind of like 6 things blockchains are better at. They're very, very good at payments. I mean, that's kind of just a native thing. They're excellent transparency engines, right? It's like supply chain, the carbon market. It's let me be able to audit and see what happened And that means that people can't cheat in the first place. If you do cheat, you leave a record and therefore, right? They're very, very good at, of all things, random number generation, which people don't kind of catch how powerful that is. But like literally sports drafts have been rigged around this answer. So like if you're a sports fan and you want your local team to be able to get the first pick, you want a real random number used to figure out that lottery, right?
Right.
They're really good at self-custody. I mean, the experience people have of blockchains today is very limited because most people are using Ethereum. The account model doesn't have the same sort of custody capabilities that the coin model does. So like in the coin model, you can do things like have the chain itself enforce rate limiting or make it so that the chain itself enforces like any one of these three keys can sign, but this key can do it quickly. This other key, it takes 24 hours before it goes through. And this third key takes 30 days. And you can overrule each other with real rules. And so all of a sudden, like, oops, I lost my key isn't so scary because you take one of those backups. Right. But if somebody steals your backup and you still have the good key, you're like, nope, I'm taking those funds back. Right. So that's the kinds of systems we can have. And when we start doing that, each one of these kind of major use cases for blockchains never really fits in just like one box. But when you have like 2 or 3 of these things, you really start to get to a place where a blockchain is going to be better at its ability to get these things done than the traditional way of doing them.
Yeah. And thinking about whether it's external or internal, what are some of the biggest risks that you face today, that Chia Network faces today?
So look, there's obviously just the sentiment's horrible out there. Now for us, our core paying customers kind of don't care. They've got real business needs and financial institutions and banking and other places to go get things done. So I think that's the shortest term kind of item, but we have always kind of known that this was coming from a regulatory perspective. We started out saying, look, you got to follow US securities laws, compliance matters. And we did. We recently filed confidentially for an offering with the SEC, which kind of culminates a long conversation we've had there. We believe that if you build something in the long term, you can kind of weather through the ups and downs here.
Yeah. And if everything goes well, what's the long-term vision?
So we think this is at least a 20 or 30 year effort. The real goal actually is to kind of get the level of adoption so high and have built enough stockholder value that we're able to slowly but surely kind of spin out the individual components. So the Red Hat software business goes out to the shareholders, and then ultimately, potentially the pre-farm, the coins that the company owns, are also sort of distributed to shareholders via either stock buybacks or dividends. And then at the end, you kind of create something like the Linux Foundation, where you've got a foundation that makes sure that the core development team can always be there. But, as more banks and governments adopt, they're going to have the same way that Linux does. You've got your Linux guy at Cisco, you've got your Linux guy at Intel, right? And I expect the exact same thing to happen with the Chia blockchain, where, you've got that kind of core ongoing Mozilla or Linux foundation, but that ultimately the company that you're currently talking with doesn't exist anymore and was kind of distributed to shareholders.
Yeah. I always like this next section. I call it my founder FAQ. So I'm going to hit you with some rapid fire questions and we'll see where we get. So I always like to open it up with this question. What's particularly hard about your job day to day?
The hardest thing about this particular job is we're doing so many things that are so novel. I joke with people in Capitol Hill and other places that the problem with our space is you go from the edges of the bleeding edges of computer science to like the 1933 and 1934 Securities Act without a sentence. So you really have to have this kind of broad expertise at a pretty expert level that no one's really pulled together before. So you do a lot of time trying to explain some really tough stuff.
Yeah. What's one thing that your technology hasn't been used for that you're kind of waiting or hoping or even maybe working on now to start using and implementing it in a particular industry? Anything come to mind?
So I'm kind of weird and boring. I'm excited about actually starting to change how international shipping works. It's going to take some time to get there, but there's no good reason why you couldn't truly automate and take a lot of the risks out of the entire process. What Chia kind of gives you the ability to do is to build all the tools that you see inside banks, but now you can make them explicit and customize them for what you're doing. And so getting rid of letters of credit in the way that international shipping and international commerce works, I think it's going to be a huge transition. So
yeah. Thinking about obviously your professional expertise in building businesses and one thing I'm always curious about for seasoned entrepreneurs like yourself is, what are some of the kind of early mistakes that businesses make or founders make when kind of setting up the infrastructure layer or even the important components of their company to build long-term. I think a lot of people start building around quote product, maybe idea versus a problem. Sometimes they start to scale without understanding what they're building towards or even what part of the business is necessary. What are some common mistakes that you see companies made or even you made yourself? And what are some ways to kind of correct and start kind of building kind of a more mature company even on the onset as an early founder?
Well, so there's a bunch of things that kind of answer that question, but I think the thing I can kind of point to quickest is you've got to really care about the problem you're after, right? You said something there where it's like people got a new technology and they're trying to find something to do with it. It's like, no, you've got to care deeply about what that problem actually is, because you're not likely to have exactly the plan you start with be the plan that really gets product market fit and goes.
Right.
And I like to say this to people a lot. You need to be willing to eat glass over the issue. Most people have no idea how much pain and setback and, how many times you will be told no. It is a very, very hard path. And if you really care about what you're trying to do, it makes it much easier to go do that. You wake up in the morning going, this battle is worth it. Let me keep fighting.
Yeah.
So that's the thing I'd say. Now, the other side of that is there's a bunch of pragmatic crap. It's like, go figure out how to not have to rebuild like your general ledger and accounting software every X years, right?
Yeah.
So some of that is just go get some best practices, because it's better to kind of get that stuff right. Because by the time you're scaling like mad, you won't want to deal with it.
Yeah.
But it really is if you're going to be all in, you got to be all in.
Right. Yeah. Thinking about how founders kind of focus on building their company and thinking about what's more, I guess, popularized around building. Previously, it was having great UI, UX, and interface and things like that, having kind of more scalable microservices built into your company. Thinking about nowadays, it seems like a lot of AI engine, a lot of MLs become extremely popular, obviously with ChatGPT becoming widely adoptable and usable. How has the impact of that type of technology, whether it's impacted positively or built internally, how has AI kind of been implemented and useful in your building process?
Well, so for us, we're more interested in, frankly, training AI on how to write Chia list.
Yeah.
That's actually an interesting tool from the code development side to be able to make yet another ease of use pattern. And Chia list was actually sort of especially relevant to the way AIs kind of think. Just again, the kind of linear mode of it and everything else, it just makes sense. But, if you're asking the general sense, right now I see AI as a really beautiful feature of a product that hasn't been shipped yet. Right.
Yeah.
And ultimately, like the old master plan for most people is go do 80% of a problem, 20% of a problem, 80% better.
Right.
And expand in later. Right. And so I think there's going to be a lot of opportunities to take AI and do interesting things that cut into incumbents' abilities. And you see this with Microsoft playing with Google on this one. Right.
Right.
But I think that can be done even at the two people in a startup mode. But again, it comes back to, okay, so what problem are you trying to solve, right? Like making developers far more efficient, that's a good problem to solve. There's a lot of leverage there if you can really do that, and we're seeing that. But I think it's to be seen by new and interesting founders of, okay, if you got a chatbot that's pretty close and is like 90% accurate, what can you do with that?
Right. I always like to ask this question. What's something in your career that you maybe weren't particularly good at, but now you're better at? Anything kind of come to mind?
Oh, probably sales. And I don't mean that, like, I've always had an ability to kind of sell the investment and the idea, but the actual, like, how do you go get somebody like the BBC to go spend hundreds of thousands to millions of dollars on something? And it's been something I've really enjoyed learning from some of the amazing professionals I've had on my teams.
Yeah.
So that's been one of the ones that, really helps. And I will tell you, it ends up making you a much better founder entrepreneur, because you can kind of think about how to engage with that when you're thinking through product and you're thinking through which direction to go. And like, sometimes, especially when you're talking about enterprise stuff, you don't have to be done with the product. You just have to have a good explanation of, here's the core that you're going to like, and here's our path to supporting some of the more sophisticated stuff you might need.
Yeah.
Right. And in that world, it's a very different world than kind of the consumer world, where it kind of has to start working immediately. But I think the core lessons about sales work both ways. It's just you have a much shorter sales cycle when you're talking about consumer, right?
Yeah. Well, thinking about founders who are needing to like incorporate a lot of stakeholders, whether enterprise sales or even mid-market, what are some clever ways, or even just if you think about the strategy and how you approach thinking about a partnership? Are you reaching out to, say, the primary decision maker, or are you reaching out to the core? How do you identify the core? What are some ways do you kind of build the funnel in regards to how to kind of not only reach out to that business, gain interest, but then kind of secure that and get a contract signed? Anything that have been helpful for other founders?
Yeah. So there's a couple things, like people talk about solution selling, and I do believe in it. And what I mean by that is you're not going to hear somebody always want to talk about your product. You're instead going to talk about the problems, right? And what you're really trying to do is cast a net to find what we call the coach. And the coach is the person in the company who's not the decision maker. So not necessarily the CEO. In fact, often that's the wrong way to go. You want somebody like in my previous company, we did subscription infrastructure. You wanted somebody in the finance team or the marketing team who had the number to be worried about their subscriber count, right?
Yeah.
And to be thinking about how could I improve that? Because if you can get that coach and then they can explain to you exactly where the pain is, now all of a sudden it's much, much easier for you to go articulate a specific message that's going to resonate and get them as coach to look really good in front of the actual decision maker, get the decision maker bought in and have momentum to get something done. Right.
Yeah.
And so it's really thinking about how do you get to those coaches as the kind of number one way to break into larger opportunities.
Yeah. 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 I always like to ask this question because I love how founders extract knowledge out of anything that they ingest, whether it's early in your career or now. What books or people have been highly impactful, highly influential in your career?
So one book that comes to mind that's kind of weird is Knowledge and the Wealth of Nations. This was describing like what it was to create wealth and how that all works.
Yeah.
It was a really fascinating book to think about what growth really was, right? And that like ideas are the actual thing and that they kind of spread over term, but the places that can create the most ideas the fastest are where the most of the wealth goes. After that, I don't remember the book, but it's the basic concept of starting from why. And it's a kind of a marketing principle of going, okay, why the hell do we care, right? It's like, hey, I've got something cool to sell you. It's like, no, look, this technology is going to secure people's civil liberties and wealth. That's the why. Yeah. Now, the how is it's got tremendous security, real self-custody. You're going to be in control of your destiny. And you're going to speed up these systems. You're going to make them more certain. You're going to trust less people. It's a different sell, right? It's like It comes from why it matters. And so that's the other one that I think was really critically important.
I love that. I know we're coming to the end of the episode here, so I want to make sure we didn't leave anything on the table. Is there any question that I didn't ask you or anything that we didn't talk about that you wanted to bring up right before we end here? Anything that we left on the table?
Well, I think the last thing I would just say is, especially in this current environment, there's a lot of noise about what I think are projects that didn't necessarily do things well. And so when people are like, there's no such thing as DeFi, it's like, yeah, well, in Ethereum, it's not really that decentralized, but there is real DeFi. And that real DeFi is going to be extremely powerful, not just businesses and governments, but, sending money back home to South America, being able to transact with people across the globe and buy like digital art that you never would have had access to and actually own it.
Yeah.
It's a really powerful set of technologies when you have true peer-to-peer financial capabilities.
Yeah. Gene, it's been such a pleasure not only learn about your experience and the evolution of technology and the internet and really thinking about how adoptable the new kind of wave of not only Web3 technology is, but, how its impact can be from a consumer level, even some of the things that we don't really see, and also on a global level and the transactions and even on supply chain, how much visibility, how much transparency, how much kind of things could be productive in a lot of ways by just having a general kind of understanding of where things are and how things are. And it's so exciting to think about the future of the technology as well. So I appreciate you being on the show. I hope you enjoyed yourself, and thank you again for being on Behind Company Lines today.
Thank you, Julian.
Of course.